The update function for the world object is called step, and its inputs are a little bit tricky, so let's take a look at them. The first parameter here represents the frame rate frequency that our physics engine uses to track through its calculations. Think of this value as the amount that we want the physics engine to move the physics world forward each computational frame. And of course, we want this value to match what the visual world update loop is doing too, otherwise things might feel off. Now, for our purposes, we make the assumption that the game is running at a solid 60 frames a second. Thus, we expect the update loop to be called 60 times a second, giving us a time slice value of 1/60. Next, we pass two values to the step function, which represent the number of iterations that the physics engine should spend solving collisions and velocities to ensure proper placement. Now, without going into too much detail, solving for collisions in an environment while also ensuring that objects aren't interpenetrating is actually a pretty cumbersome process and can't really be solved in a single pass. For example, consider if two objects are penetrating, and fixing the penetration causes a penetration collision with a new object. And of course, in turn, fixing that one may cause yet another collision, and so on and so on. As such, the physics engine will do passes over the physics object and solve the items iteratively. The number we pass in here represents how many passes Box2D should do before moving on, i.e. the higher the numbers are, the more precise the collision data, since we're iterating to find a solution. The lower the number, the less precise the collision information, but the more performant it is because we're not spending extra cycles.